In Taipei main station area, the available depth of track bed was always a critical issue. The tracks were built into two existing platforms, handed over and stripped of TRA assets in May 2004. After removing existing ballast down to the tunnel invert through the platform area, large areas with insufficient depth for a slab track system remained, meaning LVT blocks could not be specified. Throughout Taipei main station, an embedded rail system had to be designed to overcome this existing situation. Ultimately, a Dutch product, Edilon, was chosen to embed the rails within the concrete formed troughs. This is essentially a cork elastic mix that is poured next to the new rails, both securing and aligning them inside a cast-in concrete rail trough. The track form construction commenced with dowel drilling. In the same manner as the turnouts, shear dowels were drilled at regular intervals along the length of the track, using core drills. With over 10,000 holes required in the station area, 3 special drill frames were developed, each with 3 core drills operating off a central power and lubricating water supply. These worked their way along the platform tracks, drilling 3 holes 100mm deep every metre. 200mm long galvanised steel dowels were grouted into the resulting holes, using high-strength grout. This provided shear resistance to each of the slabs being poured to create the Edilon troughs. At the most critical locations, before the slab was formed and poured, a road planer was brought in. This was needed to lower the invert floor by up to 50mm, to ensure rail troughs could be set low enough to meet design. Special trough forms were used to create an embedded track slab, with 2 channels blocked out for the rails. This slab was designed for minimum depth and allowed the rails in some cases to sit just 25mm above the original concrete floor invert of the station. With the forms removed and the resulting troughs cast the length of the platform, CWR strings were hauled up and positioned in the cavities. Modified iron horses were used here. However, the shape of the trough required the rail to be hung from above the head, rather than supported from below. Once set by the track team, using offsets and curve design information, the track was ready for survey. The Hergy equipment was used throughout, ensuring that once set, the rail remained lined up with precision. Line, level, gauge and cant were all checked independently, and once the rails were signed off, track was ready for the Edilon pour. The Edilon system uses rubber pads stuck below the rails using a special epoxy grout, Dex G, and a layer of very thick, sticky material called Corkalast to embed and hold the track in place. The grout is troweled into the bottom of the troughs, filling any small voids that may be present, and the pads are rolled down and pressed into position. To ensure adequate bonding, 2 coats of a caustic primer are applied in the lead up to the Corkalast pour. This seals the concrete and ensures the Edilon grips the rail consistently. The Corkalast system uses a hardener to initiate its curing reaction. Buckets are mixed on a 1:1 ratio using a proprietary mixer. The Corkalast is pre-mixed for 1 minute to a smooth consistency. Then the hardener is added. The components are mixed for a further minute and are then ready to pour. At this point the operation becomes time critical, because with tunnel temperatures of 28 to 30 degrees Celsius, there is little more than 10 minutes from first mixing till the point where the Corkalast has solidified. The end product was manhandled in buckets, 20 kilograms at a time. This allowed a good control of quantities used and helped make sure that waste was kept to a minimum. The Corkalast was poured against the rail from the field or high side of the trough until it could be seen flowing under the foot of the rail on the low side. This is where the viscosity of the product was vital, as voids under the rail foot are not desirable. It was a simple matter, however, to visually check the flow, and once the Corkalast had appeared on the low side of the rail, additional material could be added to cover the foot completely. The Edilon was poured in 2 layers, the first encasing the foot and the second bringing the material up to the top edge of the concrete chamfer, giving the finished product a hard demarcation from the slab surface. Cross drains were blocked out before pouring, using a styrofoam material that the Edilon would not adhere to. Once the Corkalast was cured, these were stripped out, leaving a cavity under the rails for the water to flow through. The area was cleaned up, with the track work now complete.